This video is on 1 and 2 step mole calculations. So the first thing you should learn about moles is we have a mole conversion and we use something called mole town. So in the center of mole town is the mole center. And from mole center we can convert to 3 different things. We can convert to mass by having our moles travel to the mass mole. They can travel to volume village, or they can travel to the particle park. To get to any of these places, the moles need to travel on sidewalks, and their currency or fare to go across the sidewalks is their conversion factor. To convert between moles and mass, we use something called the molar mass. And that means that 1 mole is equal to the molar mass, which is grams, and we get that from our periodic table. That is calculated from the average atomic mass underneath each one of these elements. To go from moles to volume, we use the number Avogadro derived, that 1 mole of gas is equal to 22.4 liters of gas. And this only works for gases. And then to convert between moles and particles, we use Avogadro's number, 6.02 times 10 to the 23rd. And that is particles is in 1 mole. So a mole is a term of measurement. Just like how a dozen is 12 eggs, a mole of a substance is equal to 6.02 times 10 to the 23rd of that substance. So it's a huge number. The number is 602, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 3 more. So it's a huge, huge number, which is why we write it in scientific notation. And instead of saying this entire number, we just call it a mole. So this is Avogadro's number. He found it, derived it, proved it. 6.02 times 10 to the 23rd particles in a mole. And we're going to use it to convert between moles and particle. It's our key to chemistry. Okay. We talk about particles. For an element, they are called atoms. For a molecular compound, they are called molecules. And for an ionic compound, they're called ions. Okay. So an example, how to convert. We want to go from 1.25 atoms of magnesium to moles. We're going to list what we're given, 1.25 times 10 to the 23rd atoms of magnesium, and we want to convert to moles of magnesium. So I want to know if I can go in 1 step from atoms to moles. So I go up to my mole town sheet, and I want to go from atoms, that's my particle part, this is atoms, molecules, or ions. And can I go in 1 step from here to my mole center? So I'm starting here, ending here. I have 1 path in between, so I have 1 conversion factor. My conversion factor is 6.02 times 10 to the 23rd particles per 1 mole. So going back down, I can get here in 1 step. My conversion is 6.02 times 10 to the 23rd atoms per mole. So I set up my dimensional analysis just like I did for unit conversion. 1.25 times 10 to the 23rd atoms of magnesium. And then I draw my fence. Remember, my units here get dropped down to match my units at the bottom. So I write atoms of magnesium at the bottom, and I'm going from atoms to moles. So that means moles of magnesium goes on top, and my conversion factor, 6.02 times 10 to the 23rd atoms, that goes on the bottom, 6.02 times 10 to the 23rd atoms in 1 mole. I multiply across the top and divide by the bottom, and I get 0.208 moles of magnesium. Okay. Let's try another way to convert. So we've gone from moles to particles. Let's now go from moles to mass. We're going to use our molar mass here. So what really is molar mass? Well, the molar mass, or the mass of a mole, depends upon the element or the compound, and it has units of grams per mole. Okay? This tells us the number of grams in 1 mole. So this is just like the total mass of a molecule that you calculated in percent composition. Okay? So if I were to find the molar mass of hydrogen peroxide is H2O2. So I have hydrogens and oxygens. I have 2 hydrogens and 2 oxygens. So 2 hydrogens and 2 oxygens. So that means I multiply both times the mass I find on my periodic table. On my periodic table, I see that hydrogen has a mass of 1.008, and that oxygen has a mass of 16.00. So I multiply my hydrogen times 1.008 and my oxygen times 16.00. So I get 2.016 and 32.00. I add them together and I get 34.016 grams, and this is molar mass. That's the mass in 1 mole, so grams per mole. Okay? And that's the conversion factor I'm going to find when I need to convert between moles and grams. Let's do an example. I'm going to use molar mass to convert between moles and mass. Okay? So how many grams are in 9.45 moles of dinitrogen trioxide? So I start 9.45 moles, dinitrogen, 2 nitrogen, trioxide, 3 oxygens, and I want to go to grams, N2O3. I always want to start by writing what I'm given and what I'm going to. Next, I check back, can I get from moles to grams in 1 step? Well, going from moles to grams, distance between here is 1 pass, so I can get there in 1 step using my molar mass. So I can do this in 1 step using molar mass. So my molar mass, nitrogen and oxygen, 2 nitrogens, 3 oxygens. Nitrogen's molar mass is 14.01, oxygen is 16.00, so 28 and 48 gives me a molar mass of 76.02 grams per mole. And now I set up my conversions. 9.45 moles N2O3. Set my fence. 1 conversion, so 1 conversion here. I take my units and drop them down. Moles drops down. N2O3. I'm going 2 grams, N2O3. My conversion factor is 76.02 grams per 1 mole. 76.02 grams per 1 mole. I multiply across the top and divide by the bottom. I get 718 grams N2O3. Remember, you need units and your molecule for these. Okay? So I've done moles to particles, moles to grams. I'm going to do moles to volume. My conversion, 22.4 liters in 1 mole. So like I said before, this is used for just gases and is determined by Avogadro. I'm going to follow my same steps. So 2.02 moles of N2 and I want to go to liters of N2. So to get there, we said we just need one conversion factor, and that's my 22.4 liters is equal to 1 mole. So I start with my 2.02 moles of nitrogen. Remember, nitrogen's a diatomic. I have one step because I have one arrow, so I take my units and drop them down. Moles, N2 on the bottom, liters, N2 on the top, and now I go back and fill in my numbers. 22.4 liters per 1 mole, so 22.4 liters per 1 mole. I multiply across the top and divide by the bottom. 45.2 liters and 2. Okay. Now that I can do my one step, I can get a little fancier. I can start at any one of these outside places of my mole center, and I can now go between them, but I have to stay on the sidewalk. Okay. Moles don't like to stray off their sidewalks. They like to stay on them. So if I'm going from my mass to particle park, I can't take this detour across. I have to stay on the path. So I have to first go from mass to moles, then moles to particles. Or from particles to volume village, I have to go from particles to moles first. That's one step, moles to volume village. So we call moles the key because they're the hub. We have to go through my mole center in order to go anywhere else. So when I do these, I always follow the same steps, so that way I don't make mistakes. So I first want to ask myself, what am I given? So what are you given? And that's always a number. And then what are you trying to find? So what do you want to find? Once I know what I'm giving or what I want to find, I want to know how will I get there. And that's using my mole town. And then I'll use my conversions from my mole town. Because remember, our mole is the key. So, convert 10 grams of sulfur dioxide to molecules. I start with what I'm given, 10.0 grams sulfur dioxide, and I'm converting to molecules. So molecules, SO2. I look back on my mole town sheet. I'm going from grams to particles. Can I get there in one step? No. I have to first go to moles and then to particles. So I draw that. I can't get there in one step, so I first go to moles, then I can go to molecules. So 2 steps to do so. So between grams and moles, I use my molar mass. And to get between moles and molecules, I use Avogadro's number. Okay. My molar mass of sulfur dioxide, 1 sulfur, 2 oxygens, gives me a molar mass of 64.07 grams per 1 mole. Avogadro's number is 6.02 times 10 to the 23rd molecules per 1 mole. So I start with what I'm given to do my conversions, 10.0 grams sulfur dioxide. I had 2 conversions, so conversion 1 and conversion 2. My first conversion is grams to moles, so my grams drops down. And I'm going from grams to moles, so moles goes on top. And my second conversion is from moles to molecules, so moles is on the bottom, and then molecules is on top. And then I go back and fill in 64.07 grams per 1 mole, and every 1 mole, 6.02 times 10 to the 23rd molecules. Molecules. When I plug that in, multiply across the